Today we will discuss about the test for organic chemistry, which are used to distinguish the different organic compound as well as in word problems. So we will discuss one by one, chapter wise, all the tests. So first of all, silver nitrate test. In silver nitrate test, that is used for distinguish the halogen compounds like alkyl halide, benzyl halide, allyl halides, aryl halides, and vinyl halides. So when the given organic compound is treated with dilute NaOH followed by the reaction with silver nitrate solution, then a precipitate is obtained, and this precipitate can only be given by alkyl halide, benzyl halide, and allyl halide. Reason here, dilute NaOH can react with these all halide, that is alkyl, benzyl, and allyl halides, and displace the halogen. So NaX is formed. NaX reacts with silver nitrate to give the AgX precipitate, that is silver chloride, bromide, or iodide. But if there is no precipitate, then the compounds may be aryl halides or vinyl halide. So in this way, if we have to distinguish methyl chloride and chlorobenzene, then methyl chloride will give a precipitate of AgCl, but no precipitate will be obtained in case of chlorobenzene. So this is the first test, that is silver nitrate test to distinguish halogen compounds. Now, next test which we have to discuss, that is Lucas test to distinguish 1 degree, 2 degree, 3 degree alcohol. Lucas reagent is concentrated HCl with anhydrous ZnCl2. So when alcohol is treated with concentrated HCl in presence of anhydrous ZnCl2, then there are three possibilities. One is the turbidity. Turbidity means the precipitate obtained immediately. Then it is 3 degree alcohol. Tertiary alcohol will be there. What happens in this case? The alcohol reacts with HCl in presence of anhydrous ZnCl2 and gives alkyl chloride, which is insoluble. That's why a turbidity appears immediately. But turbidity, when obtained after 5 minutes, then it is 2 degree alcohol, and no turbidity appear. But it can be appear on heating only. Then it is 1 degree alcohol. And this is the test to distinguish 1 degree, 2 degree, and 3 degree alcohol. Now next test which we have to discuss, that is neutral FeCl3 test for phenol. Phenol, when we treat with neutral FeCl3 solution, then a dark violet color is obtained. And reason behind to obtain the dark violet color, what happens in this case? This FeCl3 reacts with phenol then it gives FeC6H5 whole 6 3 minus complex with HCl and 3H. And due to formation of this complex, violet color is obtained. Phenol can also change blue litmus solution to red. That can also be used to test the phenol. So this is one important point. Whenever phenol we have to distinguish with any other compound, then we will use neutral FeCl3 test, because this test is not given by any other compound. No other compound gives this neutral FeCl3 test. So whenever you have to distinguish phenol with any other compound, always use neutral FeCl3 test. Now next test which we have to discuss, that is DNP test for aldehyde and ketones. Both aldehyde and ketones give this DNP test. So when aldehyde or ketone is treated with 2,4-DNP, that is 2,4-dinitrophenylhydrazine, then a brown or red or yellow color precipitate is obtained. That may be orange also. Orange color precipitate is obtained, and that shows the presence of aldehyde or ketone. So here product obtained is 2,4-dinitrophenylhydrazone. Sodium hydrogen sulfide, both aldehyde and ketones, they give addition product with sodium hydrogen sulfide, and that also shows the presence of aldehyde and ketone. But important point, aldehydes are very much reactive with the ketones. Now, next, if we have to test only for aldehyde, then we have to test, one is the Fehling test, another is Tollens test. So Fehling test, Fehling solution has two constituents, Fehling A, aqueous copper sulfate solution. Fehling B is alkaline sodium potassium tartrate, that is also called Rochelle salt. So whenever we have to use Fehling solution, then both Fehling A and B are mixed in equal volume. So all aliphatic aldehydes on heating with Fehling solution gave a red-brown PPT. Red-brown PPT is of Cu2O. This red-brown PPT is obtained. What happens in this case? This aldehyde with Tollens, this Fehling solution gives Cu2O precipitate and aldehyde are oxidized to corresponding carboxylic acid. One important point about this, benzaldehyde or any other aromatic aldehyde do not give Fehling solution test, because when we use benzaldehyde with Fehling test, then benzaldehyde undergo Keniza-Rose reaction with Fehling solution due to alkaline medium. That's why benzaldehyde does not give Fehling test. This is one of the important point. There is another test for aldehyde, and that is Tollens test. Tollens reagent is ammonical silver nitrate, and this is used for all the aldehydes. All aldehyde gave Tollens test. So when aldehyde is heated with Tollens reagent, and then silver mirror is obtained, that is silver deposited inside the test tube and form silver mirror. So in this case, this aldehyde that get oxidized to carboxylic acid and Tollens reagent reduces into silver, which deposits by the side of test tube, that is Tollens test. So one important point, all aldehyde gives Tollens test. So whenever you have to distinguish any aldehyde with other compound, then try to use Tollens reagent instead of Fehling solution, because aromatic aldehyde do not give Fehling test. One very much important point, that is formic acid is also gave Fehlings as well as Tollens test. There is no other compound except aldehyde or formic acid gave Fehlings and Tollens test. So whenever we have to distinguish formic acid with any other carboxylic acid, then we use Fehlings and Tollens test for that. Now, sodium hydrogen carbonate test for carboxylic acid. So carboxylic acid on reaction with sodium hydrogen carbonate gave brisk effervescence due to evolution of carbon dioxide gas. So any carboxylic acid, for example, whenever you added the water in this ENO powder, then you have observed the brisk effervescence, and that is also due to the evolution of CO2 that consists the citric acid with sodium hydrogen carbonate, and as soon as we add the water, immediately they react and evolve the carbon dioxide gas. So same test we use here, that is sodium hydrogen carbonate. So whenever we have to distinguish the carboxylic acid than any other compound, then only we use the sodium hydrogen carbonate, because carboxylic acid can change blue litmus to red. Similarly, phenol can also change blue litmus to red. If we go for the esterification test, then carboxylic acid and phenol both will give the test of esterification. But sodium hydrogen carbonate test is only given by carboxylic acid. So definitely whenever you go for distinguish of carboxylic acid with any other compound, so try to use only sodium hydrogen carbonate test. So this is the test for carboxylic acid. Now iodoform test, very important test. Iodoform test is only given by the compound which have methyl ketonic group or CH3CHOH group. Any compound having any one of these two group, they give iodoform test. Like propane 2-ol, ethanol. Ethanol also gave this. Acetaldehyde, acetone, acetophenone, pentane 2-on, pentane 2-on. All these compounds give this test. So whenever the compound having CH3CHOH group or CH3CO group is heated with NaOI, sodium hypoiodide, or I2 plus NaOH, then a yellow precipitate of iodoform is obtained. We obtained a yellow precipitate. So what happens in this? If we are using I2 plus NaOH, then I2 plus NaOH also react together to give NaOI, which is the reagent here. Sodium hypoiodide is obtained like this. And this sodium hypoiodide, if we are starting with alcohol, then first it oxidizes alcohol into ketone. So again, we obtain the methyl ketonic group, which on further heating with NaOI gives a yellow precipitate of iodoform with carboxylic acid sodium salt. So iodoform test is very important. Keep in mind, it is given by alcohol having CH3CHOS group or aldehyde ketones having CH3CO group. So aldehyde, there is only one aldehyde which can give this test, that is acetaldehyde. Ethanol gives this test. Propane 2-ol give this test. Pentane 2-on, acetophenone, all these give this particular, that is the iodoform test. Now carbylamine test. Carbylamine test is given by all 1 degree amine, that is RNH2. That may be aromatic or aliphatic. Aniline also give this test. Methylamine, ethylamine, all these. So when 1 degree amine when heated with chloroform and alkali, then it gives a bad smelling isocyanide. So here, and when amine is treated with chloroform, then in presence of alkali, then it gives bad smelling isocyanide. This is isocyanide. So this is to distinguish 1 degree amine and 2 degree or 3 degree amine. One important point, sometimes it can be asked, how can you distinguish aniline and methylamine? And you people write carbylamine test will be given by methylamine and not aniline, and you get 0. Because aniline is also 1 degree amine. Aniline is C6H5NH2, and that is 1 degree amine, and will give the carbylamine test. Similarly, methylamine will also give. So whenever methylamine and methylamine and aniline, we have to distinguish. Don't use carbylamine. Go for azodite test. That is given by aniline, not methylamine. So next we have to discuss, that is Hinsberg test. Hinsberg test is used to distinguish 1 degree, 2 degree and 3 degree amine. Now question is, what is Hinsberg's reagent? So benzene sulfonyl chloride is used as Hinsberg's reagent. Benzene sulfonyl chloride, that is C6H5SO2Cl. So when amine is treated with benzene sulfonyl chloride in alkaline medium, then there are 3 possibilities. First, a soluble substance, that is clear solution, is obtained, which on acidification gives an insoluble substance, that is for 1 degree amine, that is RNH2. So benzene sulfonyl chloride with RNH2 in alkaline medium give the potassium salt, which is soluble, but when as soon as we add acid, then immediately it gives insoluble substance. So this is for 1 degree amine. Like if we go for 2 degree amine, that gives insoluble substance and remains insoluble on acidification. Acid डालने पर भी insoluble रहता है और पहले भी acid insoluble substance we obtained. So reason behind it, when we take this 2 degree amine, then it gives C6H5 SO2 and R and R. A question is why it is not reacting with HCl or not giving the potassium salt, because there is no acidic hydrogen here. That's why it does not give this soluble potassium salt which we obtained here in case of 1 degree. So it remains insoluble. 3rd degree, there is no reaction occur because there is no replaceable hydrogen in 3 degree amine. That's why it does not react with benzene sulfonyl chloride. But when we add acid in it, immediately it gives the soluble salt. So this is the difference between the 1 degree, 2 degree and 3 degree amine. 1 degree amine, it gives clear solution, but on acidification, it gives insoluble substance. 2 degree amine give insoluble substance in alkaline as well as acidic medium. 3 degree amine does not react with benzene sulfonyl chloride, but on acidification, it becomes soluble. Now, next one is azodite test. Azodite test we can use for aniline as well as phenol. Both can give this test. Aniline, first of all, on reaction with NaNO2 and HCl, undergoes diazotization at 0 to 5 degrees centigrade and gives benzene diazonium chloride. And when this benzene diazonium chloride is treated with phenol, then it gives orange color azodite. That is called dye test. So it is specific for aniline. Aniline first gives benzene diazonium chloride, which on reaction with phenol gives this orange color azodite. Orange color azodite, that is para-hydroxy azobenzene. So this is all about the different tests which are in our syllabus. Now, using these tests, we have to distinguish different compounds. A number of distinguished tests we have to use. All these tests, that is about 11, to distinguish different compound. Like it can be asked, how can you distinguish chloromethane and chlorobenzene? First, second, methanol and ethanol. Third one, 1-propanol, 2-propanol. Fourth is formaldehyde and acetaldehyde. Fifth, that is phenol and benzaldehyde. Next, benzoic acid and benzaldehyde. Benzophenone and acetophenone. Next, acetic acid and formic acid. Next one, methylamine, dimethylamine. Methylamine, aniline. acetaldehyde, acetone. Benzoic acid, and phenol. So if you will do all these, then definitely any one of these two you can obtain. So this is all about the